Well, hey there, HVAC pros and enthusiasts. Are you ready to take your skills to the next level? The HVACR Learning Network has just launched an exciting new e-learning course, High Performance Heat Pumps. And guess what? We're giving you free access to the first 2 chapters. Whether you're in the field, training for that next step, or simply want to sharpen your expertise, this course is packed with everything you need to understand and master high-performance heat pump systems, especially inverter-driven cold climate heat pumps. And the best part? You can access it anytime, anywhere, right from your favorite mobile device. It's HVACR learning made flexible and convenient for you. So what are you waiting for? Click the link. Dive into the HVACR Learning Network and start your free trial today. Your journey to HVACR mastery begins here. Well, hello everyone. Thank you so much for joining us once again on Did You Know, the ESCO HVAC Show. So this week I am actually on the road. I'm down at the Daikin Comfort Technologies factory in Waller, Texas. We're looking at new A2L equipment to see how things are transitioning in the residential as well as the light commercial and then eventually into the VRV product lines. And so we've been spending a lot of time talking about A2L refrigerants and the equipment that functions on those, but we haven't spent much time on the commercial refrigeration sector. And so today we're very blessed to have our good friend from the industry, Don Fort. How are you, sir?
I am doing fantastic, Clifton. Always a good time with you.
You know, we caught up down at AHR and was able to spend some time talking about new technologies. Oh, Paul, so the sound is echoing. Is that for both of us? I wonder if it is because I'm inside of a concrete.
I will hear an echo myself, so.
Okay. Well, hopefully it's not too bad, and I'll make sure to get things cleaned up in the post-edit of this. But Paul, thanks for joining us. Tom Tebby joining in from Cajun Country, Louisiana. And yeah. Mr. Murph out on the Jersey Shore. So as we were at AHR and we were diving into A2L and the commercial refrigeration, you had some really, really cool products that we're going to talk about here today as well. But Heatcraft really invested a lot into the design and the engineering of products going into this transition.
Absolutely.
And yeah, so I'm really excited. Oh, thanks, Howard. Appreciate that. Yeah, and there's a chance that we could have, a little bit of audio distortion. We got remote connections, but we'll try to get it to you as clear as we possibly can, and then I'll work on that post edit later, as usual. So, Don, let's talk about that commercial refrigeration transition a little bit, and I'm going to bring us over to the side here. Maybe that will reduce the bandwidth being used on the video and audio. And let's talk about this transition and just have a good, fun conversation about where our industry is at.
Yeah, Clifton, everybody's so anxious about what they don't know because there's still so many unturned over rocks and that sort of thing. But as far as we're concerned, as you mentioned in your introduction, we've invested a great deal of resources into making this simple. We made it simple. This transition is always something that's kind of difficult because people don't like to change, do they? They don't. They want things to stay the same, but that's not really logical. It's not going to happen. So we just have to try to prepare for the change and make that as comfortable as possible. Yeah.
Sure. And so when we look at the commercial refrigeration sector, we are going to see some changes. Some of that is just some adaptation of things we already know. So let's kind of start there with like the foundations, those fundamentals.
Well, the good news, Clifton, is this: we can't change the physics. They are what they are. All we can do is adjust to what refrigerant for you to make heat, to remove heat from a conditioned space, and that's all we can do. So the good news is, hey, it's not going to be as shocking as possible as some people might have in the back of their minds, because the tools are the same pretty much. They just have to be A2L compliant because we're talking about a mildly flammable refrigerant. So we don't want to have something that could complete that combustion triangle. So, okay, we have to eliminate that possible spark, from having
Right.
in that environment. And so, but by and large, what a technician will do on a daily basis working on this equipment will not be much different than what they've been doing so far. So that's the good news. We still do
Exactly.
the same, and that's also should be a point of comfort for many as they listen in.
When we look at these four bullets that Heatcraft has worked on to look at the product lines, you're really solving solutions by looking
Yes.
long term, right? You can either build a completely new product line, you can adapt an existing product line, or you can build a product that can work both in A1 as well as A2L. And that's really the lead that Heatcraft has looked at for this transition.
Yeah, and when you look at the footage there, that says it all. Two words: dual class. So we want to make it comfortable for our distributors. So they're always concerned about the stock that they have in store, and
Yeah.
we're going to sell through and make this as painless as possible. But also the technician has to be considered in this regard too. How can I make it painless for a technician, even though you choose to use a dual class unit? And so
Hmm.
this is all about. If I'm going to start with an HFC, I can do that, like for an R448, 449. But when my customer gets ready to transition, would it be nice to have an evaporator that can do both? And so that's what we spend a lot of resources to make sure this happens as painlessly and simply as possible.
Okay. So, like, let's talk about this. Like, what are we going to be looking at as we start, moving into, refrigerant leak detection and then eventually, mitigation if we do have a leak in a system?
Well, if you choose one of our dual class units, then the possibility of having that conversion is right there on the horizon, right? See, so we box that really nicely. So you see that blue box there, looks like the one I have here in my
Hey,
office.
there we go.
I have this. So the next thing is though, what comes in the box? Well, everything you need almost. And I'll talk about the almost in a moment.
Okay.
But when you look at that, we're looking at this on the screen here. What comes in the kit is very simple. You need the RDS board or refrigerant detection board, right? You need the wiring boards to actually make your physical connections to the wires. You need harnesses to make that happen. A relay that switches back and forth. And even when it comes time to mitigate, well, what's going to energize the coil and potentially a ventilation fan as well? The actual leak sensor is also supplied in the kit, and then the hardware is there and available. What we don't supply, of course, we don't give you the screwdrivers and the nut driver.
Right.
One
So
5/16
important.
nut driver can do everything with that, except for making one connection for the low voltage. You need a small blade screwdriver for that to happen. We did not supply, although we do have it in our interleak part network, the step down transformer. And the reason why is we don't know what the primary voltage is going to be. Now we stock one for 208, 230, and 240. We have that available, and then one is straight 115. But what if your primary voltage is something different than that? Well, then you have to act accordingly and just find a transformer. And here's the thing: it's 40 VA, 24 volt on the secondary side, right? Okay, so but the important thing is the spacing of the ears for the actual mounting plate itself. It's got to line up with the plate that you're going to have to mount it on. So
Yeah.
other than that, it's a 40 VA 24 volt transformer. Okay, they're a dime a dozen as far as that's concerned. So, but we prefer that you use ours because it just mounts up better because it aligns perfectly with the holes that are pre-drilled in the plate. So we've got that. And then when
Okay.
you look at you have a question?
No, no, no. I'm sorry.
Oh, and then the other thing that doesn't come is that after the box there, for mitigation purposes, outside the box. Okay, so say we've already transitioned or modified the evaporator, we call them unit coolers,
Hmm.
to accept an RDS system, and then you're not finished. Going outside the box, we have to put a check valve and a liquid line solenoid that when it's time to isolate,
Yeah.
Those two components will do that, but it has to be outside the conditioned space for that. So that's a separate box that actually comes like this. We already packaged this. So if you were to look at this, let me just open this up right quick. It won't take a minute because there are only two components in it. Okay, so we'll do that. Check valve, it's direction, of course. That's what makes it a check valve, right?
Yeah.
We check one direction. So
One way.
you get that. You did check with an arrow. Okay, you get that. And then now pay attention because this is more than just a pilot duty liquid line solenoid by UL specifications, and we had to make sure that you have the correct one. So it's got to be a gold label there.
Oh, really?
Not to spoil it, it looks like any other one,
Yep.
but it's got to be designated for full duty all the time, right? So that comes in the kit. So this goes outside the box. Check valve goes outside the box, and you're done. And in fact, we've got later on in this particular PowerPoint, it does give an example, a sample of what a one-to-one might look like when you pipe it together. Okay, so we have that. Okay.
Okay.
And that's it. So you have one little kit outside the main RDS box, refrigerant detection system box. And then what comes in the box is what you see there, right down to the tie straps. You know, they're number 10 by 3/8 blunted machine screws that have to be used. And we have those there. You need a total of 8 of those screws, and they come with the kit to mount all the hardware on the plate. And so we made it pretty straightforward. I did this in our lab many times, and I can get this down. And then it always takes longer the first time you do this to make a conversion. So you might spend 35, 40 minutes the first time, but I guarantee you do 3 or 4 of these, you're going to get that done by 20 minutes.
Okay.
All things considered, wired whole thing ready to go, and it's pretty neat to put this together. It's not as difficult or daunting as some might imagine in their heads to do that. Yeah.
Well, yeah, because if we think about, say the residential side, we have installers that are already starting to, do a lot of A2L residential split system installations, as well as ductless. And so if we look at, what is the mitigation for those? Well, it's based on refrigerant charge, and it's based on the flammability of the refrigerant. So in some cases, you don't even have to have mitigation. In certain scenarios, you have to have some ventilation. And in larger refrigerant capacities, you end up doing the same principle with the residential system where you're using an isolation valve to be able to pump that system down and get the refrigerant out of the indoor space and just to make sure that it's outdoor, right?
Mm-hmm.
It's kind of the same principle here in commercial refrigeration, isn't it?
Yeah. I mean, again, we're talking about human beings and conditioning the air or the space that you're going to be dwelling in. So making that safe regardless of whether it's cold storage or comfort cooling, so that's going to be the same pretty much thing to make sure that people are safe regardless of where you're standing for that. Yeah, so that you're right. It is really, really similar for that to happen.
Okay. So if we think about a new installation, you've designed these so that you can use the fan coil in a A1 installation or an A2L installation. When we go into A2L installation, we're going to have to determine the level of mitigation based on our total refrigerant charge and the inside space of the box, however many evaporators. Where does that information come from?
Well, again, we made the transition simple. Our main tool for determining these things is called the hub. Within the hub, and once you do a box load calculation, so now we know what you're dealing with as far as square footage is concerned. Then the hub's going to guide you into what you need to be mindful of as far as the actual size and capacity of the system and making sure that you have what level of mitigation you might need. So then it's just a matter of now, if I'm going to configure this, and we call that configuring a system, right? I need to make sure that these boxes are checked to make sure I get what I need on the job site when it's delivered or wherever my distributor is to pick that up there. And so you're guided by we call it the hub. It's a modeling tool. If you do not know your box load, there's a box load calculator embedded in our online system for that to happen. Just plug in your numbers, whether you're going to have normal or heavy usage of that box, in and out the doors more than the usual or not. So it's going to give you two different figures for that. Just tell it that, and it'll just guide you through what you need to be sure about in getting the A2L done. Because to your point, depending on the size of that space, if I have to mitigate, then I might have to isolate, and even in some cases have a isolation. I have a fan to come on to actually move that air, to clear the air inside that space, so it doesn't get too high over the LFL is concerned. So that's it's pretty straightforward. So
Okay.
just to recap, we have software to help you to do that. Yeah.
Yeah, and if we're designing a walk-in cooler or a walk-in freezer, we're already using the tool to be able to select the equipment. So
Yes.
all of our sizing is already in. We know the capacity of it. We know the installation area. Now we know the capacity, which is going to give us our refrigerant charge. So we're not even doing the calculating. We're just going through and determining, um, you know, what box I need to put in with this, or it's already told me which box that I need.
Yeah, and you need to do the work first up front, because there's nothing worse than missizing a system. It can be either too large or too small. It needs to be like Goldilocks, just right for that to happen.
I agree.
So we do that on the front end. So we make the proper selection. So now we know what we're getting. We know that it's capable of doing that. Now we just have to install it. So, hey, size it right, install it right, and it's going to be all tight and ready to go, as far as the customer is concerned. So we want to give that system the best chance possible of actually being a good, tight system that's going to last you for years, trouble-free.
Now, I know, like in the residential side, we do have a M1 calculation that really determines that we don't need any mitigation based on the installation conditions. Will we ever see that in commercial refrigeration where there's no mitigation necessary?
Yes, for box sizes small enough, and that's why the guidance in just to keep you not honest, but to keep you from getting into trouble.
Yeah. Yeah.
There are similar mitigation zones depending on how much refrigerant is in that system. So anywhere from 8 pounds all up to just under 200 pounds for large commercial warehouses, for that can happen. You'll know when those mitigation steps have to be employed. Yes, yeah.
Okay. So there's the potential that we might not have any mitigation, and it's the same as an A1 installation.
Yeah.
If we do move into that first stage, all we're doing is isolating that indoor unit. So we're putting that 100% closed shut off valve on the liquid line,
Hmm.
probably, I'm assuming, allowing that to pump down for a little period of time. And we have our check valve already in the suction so that as that pressure comes down, as we've removed and boiled off that refrigerant from the indoor unit, whenever we shut off, our check valve is going to hold us closed on the suction side, and our liquid solenoid is going to hold us closed off on the liquid side. And so
Right.
that's the whole reason to have those outside of the box, is now we've isolated all of the refrigerant outside of the box.
Right. And we have one more help in that regard too. On the main header, on all of the evaporators, our unit coolers there's a Schrader port right there on the
Yeah.
main header inside. So if you want to help that along, guess what? Technician goes inside, hooks up to that. I call it a utility header. Because now I can go ahead and start evacuating right for the or recovering whatever
Yeah,
what's
whatever's
left what's left in the coil. And now we're talking about just what's in that coil.
Yep.
How much do we have in the coil? Pull that out. Now you can do whatever you want to, as far as replacing the coil, hopefully finding a leak at some point. Now I can even pressurize that section that's isolated with dry nitrogen. Find the leak, with a leak detector. Then if it's in a repairable spot, do it. Get that back in service, and there you go. Right.
Oh, okay. So actually, I got another. Well, it can relate to this one.
Good.
So what if we have multiple evaporators? Do we have to shut down all of the evaporators?
It depends on the space you have.
Okay.
Right. Because here's the thing. Uh, if you have multiples, for example, and they have two separate condensers, there's scenarios in the software, depending on how you're going to pipe these units to get these, because it's all about total system charge. So
Right.
how much releasable charge do I have in this system? If it exceeds that, then we have to shut them down. And the thing about that, depending on the amount of leakage, these sensors going to pick that up. Even if you have one, say you have an evaporator here and one, 5 feet away from it or 10 feet away from it, it's going to sniff at some point itself. It might be delayed in getting that alarm to go on that one as well, but okay, it's in the same space, right? Okay,
Right.
so okay, that's likely going to happen. And
Okay.
we have to, this is one of those things we have to kind of use for a while. On every transition period, what we think might happen is not always what will happen, right? Right.
I've had kids. I understand.
Of course, of course. And so, because that's so, let's just do our best to size this properly, to do our mitigation properly as far as having the components ready to do that when needed, and then and go to town. But again, back to your initial comment, yeah, the software is going to help you make sure that I don't exceed my minimum releasable charge, my maximum releasable charge in that system. And that's going to be a wide swath because we don't know how big the box is. That's going
Exactly.
to go from situation to situation, with box about from place to place. If it's a convenience store, if it's a large cold storage warehouse, you've got different scenarios all over the place. There's so many sizes, and that's one thing that's a bit of a challenge when you talk about refrigeration as opposed to air conditioning, because you have so many variables as far as components. What we need to accomplish on some refrigeration systems will not. It's not just comfort cooling. We have to take into consideration. Well, how much shrinkage is going to be available? Do I need a low velocity system or not? That those kind of things have to be talked about ahead of time before they even go out to the job site to install anything, right? See, so there's just a lot of different flavors in that ice cream.
Yeah, absolutely. That was one of the things I really enjoyed about the commercial refrigeration industry is every job looks different.
Yeah. There's no room to be oh, bored. I don't think that's going to come to my vocabulary with this.
Oh, yeah.
Refrigeration is concerned. Yeah, yeah. So,
That's right. We are so grateful to have Don with us today. He just has helped me understand this transition so much better. Coming from the refrigeration background, I was anticipating a lot of hiccups. Just knowing that we have a lot of refrigerants to deal with, and there's going to be a variety of applications. But once Don and I sat down and went, that really it makes so much sense. Say we have. Here's an instance. You walk into a gas station and you have a nice long line of glass door coolers all in one box. May
mhm.
have 6 different evaporators. In this type of a scenario, if I have a very small leak on one of those evaporators, it could actually isolate that one evaporator, give us an alarm, and still maintain operation. It's not like we're completely shutting the system down. So, at what point of the lower flammability limit do we start getting any alarm?
We've chosen an alarm system that steps, and this is what I
Oh,
mean by that. So when you look at that board, you see on the illustration you have showed on the component locations, there is a multicolored LED on that board. Kind of hard to see here because it's very small within this
sure.
image here. But just for the sake of explaining how this works. So when we reach 25%, now this is by S-ray standards of LFL, we have to start the mitigation process, don't we? Okay.
Yes.
We're going to give you a warning, though. We're not going to shut down, but we have an alarm connection that's linked to that. If you look across the top of that board there, you've got a black uh, plug that's a plug in for some wires to
Oh,
be
yeah.
brought over to a mitigation, either a horn or a flashing LED
Visual.
light for that to happen. Because you're not going to be inside you might be inside the walk-in cooler, but chances are you're going to be somewhere away from that if it does sound off, right? So you need to have some kind of warning for that to happen. So we're going to warn you first. If that continues to rise as far as concentration in that space, now we're going to the next level is to take you up to mitigation. And now here's where we start isolating the evaporator, and hopefully the horn's going by that time. Now that's made by others, but it does make perfect sense for you to have some kind of signal outside the box to let you know something's changed. Otherwise, if it's connected to one of our intelligent controllers, there'll be a signal on the board as far as the display is concerned, but you might not be in front of the board. Now, that's
True.
why you might need a horn or some kind of strobe light to let you know, oh, something's afoot, something is afoot in my
Right.
walking cooler, as far as that's concerned. So, okay, so, but you have that. So it's a stage. Now, there are cheaper mitigation devices in this, but we want to give you a warning. So we chose this one, the stage, before we actually isolate it, just cut off all refrigeration on that particular situation there. So
Okay.
that's a nice feature to have ahead of time. You know.
Now, looking at this control board, so I'm assuming that we have a location within the electrical panel compartment, probably the
Yeah.
right-hand side of the coil as facing it. What about the location of the refrigerant detection sensor or potentially sensors, maybe?
Oh yeah. So that was a recent change as far as the requirements is from ASHRAE, or that's probably UL as far as
Mhm.
the governing agency. But if you notice that, if you're looking at the picture there, there's one picture of all the components that's to the extreme left.
Yep.
Right next to it is when you open up that has a hinge that when you take that one five sixteen
Front
screw
cover.
between the cover that swings open,
Mhm.
and you see at the lower level of that hinge plate is where the actual sensor is mounted. Now, if you notice the relationship, now this is kind of small, especially for the audience here, but it's right above the condensate drain pan.
Oh, sure.
Now we all know that A2Ls are heavier than air. So if I do have a leak, it's going to tend to pool. So that's why we put down low. So if it pools there of a high enough concentration for that sensor to sniff out, well, I've got A2L present here. That's why it's mounted there. You'll notice that it's mounted at a slight angle on purpose there, because if this is in a cold, moist environment, we
Mm,
could we could have some moisture. If we
condensation.
do, we need to have that moisture not just stay there and stagnate. We want it to roll off
Mm.
and drip down out of the way. So it's purposely mounted, at an angle so that happens naturally for that to happen. So, but it's down low, so you mount this right above the condensate drain pan. So when you close that door up, guess what? It's mounted really nice next to the coil, down low by the condensate drain. If I do have a A2L leak, if it pools enough, guess what? I'm going to pick that up and start my mitigation process after that.
Okay.
Now, the standard before, I can't remember when they made the shift, but originally when we had these sensors in place, the requirement was to have a sensor on both sides of the coil. So
Mm.
on this side, but also on the left side of the coil as well. Two sensors for that one evaporator, right? Now it's okay to use one sensor. So, but if you'll notice that the mitigation board across that bottom edge, there are three connector points for three different sensors.
I've seen that.
There's a four switch uh, 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 mini switch assembly to uh, micro switches to make sure that we have the mitigation process that's the sensor sensing the right one. So the going from right to left, that first space on that force that square plug, the Molex plug there is sensor one, then two, then three. So we will put that now with one sensor. We'll put that on the first plug. That's plug number one. We'll do our switch, make sure that our micro switch is the number one switch is in the on position, and then the other three switches they're closed as far as that's concerned. So it's really really good, straightforward for your dip switches to be lined up that way. So it's pretty straightforward. These are not difficult to install at all when it
Yeah.
comes time to make this conversion from an A1 to an A2L refrigerant.
Josh brought up a question, and we've probably not had them in the field long enough to know for sure on this, but it's a question worth asking.
Yeah.
We always have that one unit that we get the call and they say, I don't know, something's not working, and we've got 6 inches of ice built up in the bottom of the thing. It is when we do have those, I mean, because it's definitely, it's not an equipment issue, it's a customer issue that, has introduced, one of these components into an ice. Is it going to be a recommended procedure to replace those sensors, or how are they tending to manage in those conditions?
Well, if you look at the way this stands away, that would have to be. Now, I'm not saying it's impossible to have that much ice built up
It's a lot.
with a sensor,
Yeah,
because we're talking about maybe 3 inches of ice in
exactly.
that sector around that particular sensor is concerned. Um, I can't see that happening, but in the abundance of caution, that is replaceable.
Yeah.
So, I mean, you've got two 5/16 screws that hold that in place. Unplug it, it's there. I mean, so that's that. I mean, it's pretty straightforward. But I can't see just ice blocked up,
That,
getting impinging upon this. You'd see that more readily on the manifold side of that coil on the left hand side around the expansion device in that area,
mhm.
balling by ice balling that way, as opposed to the other side. That almost never happens, as far as that's concerned. But if it does, it's not going to take the whole system out. At worst, that sensor. That's it. So
I've been noticing in the residential and light commercial sector, we're anticipating approximately a 15-year life expectancy out of sensors. Do we have an anticipation on life expectancy on commercial side yet?
I have not seen that data. However, that is a pretty good standard to go by.
Mhm.
15 years is a pretty well standard. And only reason to say that is even the little battery that runs the clock on our intelligent controller, it's good for 10 years before you have to replace it. So that range of and of course it kind of depends on where you put it. Is this a Seacoast application? Are you holding product that actually off gases a lot? So you're going to have some accurate, air, that's VOCs in the air that's doing some damage that wouldn't be across the board damage. So it kind of depends on where is this thing dwelling, what is it being exposed to, and how long. So we can't just rubber stamp that because there's a whole variety of different product that's being stored in walk-in coolers. So kind of depends. It depends. I hate to say that, but it's the truth.
It is absolutely the truth. I've walked into some coolers before and went, I didn't anticipate to find this in here.
Right. Okay.
All right. So let's dive into this one just a little bit.
Yeah, kind of spoke to this already a few moments ago, but now on the left
Yeah.
there's an example of what you'd expect. Now, as far as hanging the evaporator, that's not going to change. It still has to be level. It has to be spaced right as far as your clearances from the wall and the sides. All that is in your owner's manual for the devices that you'll be installing. But outside the box there, you see, we want to put that as close to the walk-in as possible because I was in California, and a technician asked me, I was doing another training session, and he says, well, why don't you just put that in the condensing unit, and you have that ready to go, and we'll just pipe it up and go. Okay. So let's talk about that. Take that to the natural conclusion. Okay. So I've got this thing piped and I have it charged properly. I've cleared my sight glass and everything like that. It's holding temperature, but now I got a leak. So if I mitigate it outside at the condenser, let's say it's 50 feet away. That's 50 feet of pipe in addition to what's in the coil. Too much.
Right.
All that's going to go is fill into the box. No, I've got to have it as close to the box as possible and let that isolated state. Let's stay outside, away from this space that I'm trying to protect from having too much A2L impinging in the air because it's going to displace oxygen. Not a good scenario as far as that's concerned. So no, we can't pre-install these as much as that would be. That would simplify a lot of people's lives.
Mhm.
But you see the logic. What if it's 100 feet? Well, that's 100 feet of pipe full of refrigerant. Okay, might not want to do that in that regard there. So okay, that's why it's so close to the box, as close as possible. So we mitigate the amount of additional refrigerant that might be in the lines in your piping. So that's how that has to go. Yeah.
Yeah, makes complete sense to me. Robert had a question, and I'm actually going to do a class here in a couple weeks and dive into the technologies that the sensors are actually using, because there is a variety of different
Yeah.
technologies. It's not a one technology fits the bill for every type of sensor. So this will be different based on the technology in the sensor itself. But
Mhm.
have you seen any type of like self-diagnostic or ways of doing any test on any of the mitigation systems?
It's built into the board.
Ah,
So you can test it. There's a micro switch right there. Hold it down. It'll go through a diagnostic cycle. If it passes, great. If not, it's going to give you a warning as far as that's concerned. Now the sensor that we've chosen is one sensor that fits the three refrigerants we're going to offer for A2Ls. So we have R454A and C and 455A. So these three refrigerants can be sensed by the same sensor. Yeah. Now, if they come to one of our in-person classes, we will actually have to demonstrate with an ohm meter how we can check that out on a bench. So, but you got to come and visit me. But right now, the test is going to be a button. Push the button, let it go. It goes to a self-diagnostic to that point, automatic anyway. So once you power it up, for 5 minutes, it's going to be flashing as it's testing all the components.
okay.
Then it'll settle down on a nice green light after that. So it'll tell you right up front whether it's going to pass the test of custom mustard, as far as that's concerned, right? See, so yeah, it's just pushing the button. It's almost like your smoke detectors and your fire detectors. You got that test button there to make sure that it works. Same principle as far as that's concerned. And so,
Excellent.
yeah.
Well, I can't wait to come see you. And for everyone out there, we're actually planning on a road show. We'll fill you in more on that later as we get closer. But that'll be one of the things that I look forward to doing is sitting in on that class. Maybe we can encourage some more people to join us and have a big classroom education on that.
Absolutely.
Okay. As well as the residential and like commercial, all applications using a A2L refrigerant will have some type of labeling. What will we see in commercial?
Well, on the evaporator or unit coolers on the side, there's an amen. So it does tell you what the maximum releasable charge is for that particular location. So that keeps you honest as far as what you size this for.
Right.
Is this too big for the space that you're trying to put this into? So you've got that. You notice that on the cover here of this bone unit you see displayed here, the labeling for this dual class unit, okay, comes in the packet with the instructions for installation. All those kinds of things are in the packet there, and that label comes in the packet as well. So once you finish and get that done, change the A1 to an A2L unit, put that label on the front. Now everybody knows from that point forward, oh, this is now an A2L system. Now, as far as the condenser is concerned, it's going to come labeled as well. You'll notice that on that labeling, you see that little U shaped I've got that highlighted with a red circle on it.
I do.
See that? On that, because again, this is guidance from our governing agencies. But I'll just read what's on there. We'll expound upon this in a little bit. So it says, notice, receiver pressure relief devices and fusible plugs shall be discharged to a location at least 15 feet above adjoining ground level and at least 20 feet from any window, ventilation opening, or exit in any building. So this is when you have a condenser in a larger space. You've seen those that on a small walk-in cooler, even in a large space there. Yep. Okay, so now it's inside, it's not outdoors.
Yeah, sitting on top.
That's what they're telling us. Okay, 15 and then 20 feet, depending on where you are, ground level or around any opening or where you'd have traffic going in there. They're saying, okay, so now I've got to take this away. So what does that mean? Well, when you look at our unit, our condensing units on that receiver where the fusible plug would be, it's still a fusible plug there, but you'll see there'll be a cap like you'd see on a Schrader valve. A
Right.
cap there,
Threaded.
threaded cap, same, it's quarter inch fitted like it would be for a hose set, right? For that.
Mhm.
But then you'd have to open up that little horseshoe there, knock that out to knockout, really, and then run that line, that quarter-inch line outside the knockout, and there you go. Now make your 15 or 20 feet away from it at that point, if you have to, on an indoor application. So the fusible plug is there already. If you got one from us, right? It's capped. You can take the cap off, put the adapter on, run your quarter-inch line out that little knockout there, and now you're in compliance as far as that. Well, run it out 15 feet, and then you're in compliance.
Yeah, or outside. I see this as a perfect application for that. So for those of you who are not familiar with this, all refrigeration systems have a high pressure relief of some type. And
Yes.
as we move into A2Ls, now we have a required pressure relief valve in case there is a catastrophic issue within the system. We have very high operating pressure on the high side, and we would want to remove enough refrigerant to reduce the pressure of that system back into a safe operating range. We would potentially have to release some refrigerant. Well, we don't just want to dump it into a kitchen full of ovens and
Oh, yeah, that would not be good.
open flame. So in this application where your condensing unit is indoors, we're simply going to relook at where that potential release of refrigerant should be in this installation. So very simple specifications. I mean, it doesn't sound
Yeah,
difficult at all.
yeah, and really not a stumbling block over and above what we already do. Because to your point, Clifton, if you had a catastrophic failure, guess what? And it did take the fusible plug out. Even with an HFC, you got to replace the plug,
Hmm?
right? For this, you got to do the same thing. Replace the plug, hook it back up to the lines that you run through there, and you're back in business. Well, fix what caused the catastrophic failure too. Do that first, then
Yeah.
put the plug in. Now we're ready to go. So there was a reason why you did that in the first place. Now, what was that? What was
Yeah.
that? Fix that, and then we can get it back. So because you'd have to replace the plug anyway, you would. Yeah, so this just extends this out so we don't have, to your point, A2Ls pooling around a stove
Right.
or a pressure fryer. My old KFC days, I did plenty of restaurant service back in the day, as far as that's concerned. But yeah, we don't want that to happen with flammable refrigerants around. Okay, so, yeah,
No.
that's what that means as far as that's concerned. So the labeling is there. It's very important. You see, there's spaces for you to put the type of refrigerant you have and the amount of charge you have too. So now and that's a courtesy for the next guy, and just for your information, your company's information. Just make sure that what you got, what type you have, and how much of that do I have. So that's on record for that particular system. Now you know what you're dealing with.
Very, very cool.
Yeah, yeah. So
Well, how about that? It's back to just us now.
wow. Yes.
Let's see if there's any questions out there. And I was anticipating we'd have 50 slides to go through, and here we are at 12, and I'm going, we probably could have done it in 2 or 3 because it's really not as significant of a transition as many would anticipate. So, yeah,
Well,
if
that's a
anyone
good thing.
has questions, let us know. I know I did have one, Don, because I want to potentially correct myself. So in your units on those relief, those are going to be a refuse, a single use relief. Am I understanding
Yes,
that?
it is. Mhm.
Okay.
It's
Um,
not like, for CO2, you've got multi-use relief valves come in play, but this is a single use. In fact, can I share my screen?
oh, absolutely, you can. Yeah, down at the bottom there should be a plus sign that you can add.
Okay, let's see.
And Josh, Here's a question that came in. Josh was asking, should we be keeping the sensors on hand? Because if we have a sensor failure, we're going to have a shutdown of the system that will not operate. One thing that I've seen in most manufacturers in the residential sector is the potential to put those in a standby mode if we have a sensor failure. Is that something available in the commercial sector, or is it going to have to be replaced immediately if we were to have a failed sensor?
It's going to have to be replaced immediately. They don't want
Okay.
you to bypass anything for sure. So
Yeah.
I'm not seeing, I see the plus sign. I've got this up. It's not allowing me. Let's see. Microsoft Edge, Windows, entire scope. I'm cooking now. Let me
Okay.
this here. Okay, share this. All right. If you can see this, this is on an actual plug. So if you see in the corner here that there's that's where that's where your liquid receiver is.
Oh.
On that side piece where the fusible link would be, that plug would be right there. If you know if this is extended, so there you have a cap. You've got the fusible link, but now you just take the cap off, complete your run of pipe on out, and make the requirements for either 15 or 20 feet, depending on your application is concerned. And that's what we're talking about. So a fusible plug would be like the one we have here. This is one that has threads on the outside. So you have a male threads in here, right? So to go ahead and complete that transition on out away from the conditioned space. So that's what you would see. If you pop the top on an A2L condenser that we supply, that's what you would see. It's marked with a red tag to let you know, oh, this is for A2L. Okay, yeah. And you got the threaded piece just ready to go to accept a connector to go ahead and take that on outside from that. So it's that simple as far as that's concerned, right? Okay.
Nice. Okay. Yeah. Thank you for the clarification, because I wanted to make sure, because I had seen in regulations it could be either, and I just wanted to see where I was. Oh,
No problem.
Miguel, great question. I'm glad you brought that up.
What was that Miguel said? Let's see.
When are we planning to see A2L commercial refrigeration equipment?
Right now.
Right
Right now.
here, Miguel.
It's ready to go. It's ready to order right now as we speak. As we speak. Just go ahead, Miguel. Order a parcel of them. As I say in the South, just order a parcel of them.
That's
We'll
right.
go ahead and take care of you as far as that's concerned, right?
So, Don, when we start looking at commercial refrigerants, what refrigerants will we see the most in these lower GWP replacements?
Well, right now, our 450, we chose three, R454A and C, and 455A. Now, we've had some for some of our configured to order systems that were medium temperature that went with our 455B. So that's possible on demand depending on the application. But you're going to see those three refrigerants more often than not, because as far as glide is concerned and hitting your TDs are concerned, yeah, you're going to suffer a little bit as far as capacity. So you might have a little bit difference as far as sizing the systems, but overall, it's going to function pretty much like the ones you are using right now, your HFOs, right? Because they're, when you look at the TV charts, temperature pressure charts, then you're going to see, okay, it's tracking, but there may be some variances as you go down the temperature band as far as that's concerned. But yeah, we're going to see that. The good news is same POE oil is being used on this, so I don't have to change that. So that's why you can use the same pipe, similar pressures, same lubricants are used when you do convert, right? As far as that's concerned. And so that's not even an issue anymore. Not like maybe the old 1992, we had the old R12, switch over to R, at the time 134A, right?
Yeah.
People were crying a river. I can't use mineral oil anymore. Oh no, I can't use. I got to use this. What is this POE? Okay, man. So, but we got through that. We're still here, right? We did. Right?
We made it.
Just make the change and go about your business. That's it. It's not going to stop us. It might be a little bit of a roadblock or something we have to go around, but we'll find a way to do that as painlessly as possible. Will there be some angst and some pain? Of course there will be. Anytime you change, you're going to, right? But when we get this cooking, we'll find out, just like we did in the R12 days.
Mm-hmm.
We had guys, oh man, this is hydroscopic. It absorbs moisture too quick. How can I do even a seal system in time before it gets too contaminated? Well, we don't hear that anymore, do we?
Right.
It's not quite as touchy as they said it was going to be.
Yeah.
So just go ahead and do the work and see what happens.
Yeah, if you do it right, there's no concerns anyhow.
That's right. We shouldn't do it right anyway. So yeah, we need to pull a deep vacuum, right? We make sure we're not leaking. Clean, dry, tight. That's what I preach all the time. If we do that, guess what? It's going to work and work well.
Mm-hmm.
So that's just the facts of the matter as far as that's concerned. Yeah.
I agree.
Yeah.
And, for those that are unfamiliar with these new refrigerants, if we think about 400 series refrigerants, all 400 series refrigerants are blends, including R410A, which was a blend of 32 and 125. When we start talking about these refrigerants like 454A and 454C, and then you have the residential and like commercial, the AC going, wait a minute, there's a 454B in there as well. How are they related? Well, if you'll go back to any of our refrigerant classes, you'll see that those capital A's, like in 454A, B, and C, are just different blends of 32 and R1234YF that allows them to function for specific applications. So that system, once it's designed for one refrigerant, is designed for that refrigerant, no other.
Yeah, that's right. Yeah, you're right. That's a good point, because it will work. It just won't work like it's supposed to. It will move some heat, but don't expect it to act like it's supposed to as far as TDs are concerned, because
Exactly.
you don't have the right stuff in there. That's like the old days when you had leaded fuel on cars, right?
Mm-hmm.
Okay, so you had a certain, and like my car, unfortunately, I've got to use premium gas. If I try to pump some of that low dollar stuff in, it's not gonna like me. Okay, specifically for that engine, right? Okay, so it just goes to show there's more than one application for using the right specified refrigerants all the time. Do that, and then you'll get yourself out of trouble instead of getting into trouble.
Love it.
Yeah, that's for sure. That's for sure. Yeah.
Any other questions out there? If not, I've got a really cool video that Don and I did at AHR. I think I'm going to go ahead and share that since we've got enough time left. And if anybody has any questions, go ahead and put those into the chat for us, and then we'll be able to answer those when we get back. I think this one was about 6 minutes. Let me go find where that's at.
We talking that long?
It was. It's hard to believe, isn't it? Uh-oh. It didn't load. That's not good. Let me go look one other place while we're waiting to see if anything else comes in. Well, that little turkey.
Well, I don't feel so bad now. See, they don't know it, but I had to reboot my whole computer before we got on the air.
Right?
I was sweating bullets for a while. Man, come on, I can't log onto this site.
Yeah, we were like down to the minute of getting things uploaded. So, then I will encourage all of you to go over to our YouTube channel. I'm doing a large push right now for everyone to subscribe to our channel. We have tens and tens of thousands of viewers. We're running 80 to 100,000 views a month right now on YouTube, and not everyone has been subscribing. So I'm encouraging you to subscribe to the channel. That way you get these notifications when we go live and when we post new fun videos like the one that Don and I did at AHR. So if you go over to the YouTube channel, you'll see that video, and we'll actually have one of these new dual purpose A1/A2L systems to be able to show you what that looks like. It's a really cool display.
Great.
Well, sir, I think that is about it. How can we connect with Heatcraft to learn about the amazing products and all of the training that Heatcraft provides to the industry?
I'm glad you asked. Go to our website, heatcraftrpd.com. Hit the training tab and there'll be a drop down to tell you what's available and when it's available. Really simple. Really simple.
RTD.com. I'll throw this down into the bottom. We'll get that up, let that run for a minute, see what we got in the chat here. Okay, well, fantastic. Thank you for the link on that. So in the chat is a link to that video. So you can go check that out. Mr. Ford, I'm so grateful that you spent time with us today. And I look forward to this transition. I enjoy being with professionals like yourself who are just bringing a positive perspective to this sometimes difficult transition. And it's really not that bad when you know what you're doing. So we're so grateful for you.
And I am grateful as well, Clifton. It's always a pleasure to speak with you and others. And of course, I've been teaching for a long time, been in this trade for 41 years, and I still love it. It's that spark is still there to actually help people know and understand and feel comfortable with moving heat. We're making liquid, moving heat. That's what we're doing.
All right, everyone. Thank you so much for joining us. We're grateful that you took time in your day to spend your time with us. We will see you all again next week on Did You Know? The ESCO HVAC Show. Bye, everybody.
Ta-ta.